Cool, awesome. Let's get started. My name is Jesse. I am an engineering manager at PyTorch within Meta. Prior to my joining PyTorch, I was trying to leverage LLMs in products and services that we were building and found it to be really challenging. I noticed that PyTorch was driving the way forward and trying to make it easier. And so I actually stopped what I was doing and joined PyTorch so that I could work on this problem and make it a lot easier for anybody to run LLMs kind of anywhere. And now I get to work with people like Jack.
Hello, everyone. My name is Jack. I've been at Meta for the last little over 4 years at this point, mainly on PyTorch Edge and Mobile, focused on the productivity and experience side of things. With that, let's get started. So, LLMs, they don't need much introduction. Over the last year, 2 years, they've ingrained themselves throughout our lives, throughout society. Everyone's heard of ChatGPT, Apple Intelligence. You have smart glasses, which these are not because I forgot to bring them. But backing all of these is just LLM model inference. You're taking these pre-trained models that take an integer input and an integer output, and they're wrapping it in a way that's more useful, hackable, understandable for these applications. And these models, you've definitely heard of them. Something like you have your Lavas, you have your Mistrals, you have like your Orcas. And this is actually where Torchchat comes in. Torchchat is PyTorch's LLM inference solution. And today we're going to be looking at a bunch of our offerings, a bunch of our features, as well as some demos at the end as well. As a pipeline solution, Torchchat goes from the actual model download all the way through some actual sample applications, starting with either a checkpoint that you download from Hugging Face or a checkpoint that you provide yourself. We then create and load that checkpoint into an actual model and wrap the inputs and outputs to that model in a way that is useful for some sample applications that we show. On top of showing how to do LLM inference and applications efficiently using the newest features from PyTorch, we're also consciously working to make the process of enabling LLMs in PyTorch as easy as possible. So why PyTorch? Well, why Torchchat? Starting off with the first two, it's mostly experimentation for the first two. If you have a particular model, say you have a particular flavor of Llama 3.1 that you want to play around with, and you've only been running it on your laptop, and you're now interested in just trying it out on, say, sending it on a server, running it on your phone on an edge device, or like on an embedded chip, or eventually in a distributed setting, which we'll support later this year, you can take this same model, the same quantization scheme, the same features that you've already created, that you're already familiar with, and just deploy it to these other platforms, all within the same repo. On the flip side, if you have a particular path, a particular platform you're trying to deliver to try to put applications on, but you're not necessarily sure which model you want to use, in Torchchat, it's as simple as switching the name of the model, just choosing a different model to play around with, and all those other features, all those other platforms are still accessible to you. Moving on to the next two. The next two are actually my favorite. First one is availability. Once you have that checkpoint, either provided locally or already downloaded from Hugging Face, you no longer need the network, you no longer need connection. You can run model inference, you can run these applications on your own device. And I'm emphasizing your own device here because that's one of the targets that Torchchat is actively working on. We want to make sure that LLM inference works on commercial devices. You shouldn't need a $10,000, $20,000, $100,000 machine just to play with LLM inference, just to build out these applications and test out the state of the art. This kind of leads into the next one as well, where with Torchchat, we're trying to target a broad audience. Whether you're coming from a background that isn't super CS heavy, not super programming heavy, or you just want to play around without changing any code, you can do that with Torchchat. You just download it, the CLI works out of the box, you can use Open AI API, and everything just works. But if you are interested in like testing out the optimizations or just delivering on a particular platform or on a custom platform, you can just take those particular components out of Torchchat, mix them into your own project, And it should just like work out of the box. You just grab what you need, discard the rest, and you're good. This leads to my last point, which I just want to emphasize one more time, is that Torchchat is an end-to-end pipeline, end-to-end solution. We provide the full pipeline from the actual model, the checkpoint acquisition, model construction, all the way to some sample applications that we show off. As for the design decisions that we're making while doing this, we have these three main ones that I want to touch on today. The first one is that Torchchat is native PyTorch. So what does that mean? By native PyTorch, we mean that the core functionality is being written in PyTorch with like PyTorch style and integrations. What this means is we can easily leverage all these other libraries without much effort. We are currently, and it's very easy for us to, leverage, say, torchao for any quantization or optimization needs. We're also relying on Torch compile to help us speed up our inference time, as well as AOTI. You learned about earlier today and yesterday as well from the keynote about TorchTune. So we're going to be leaning on TorchTune for any of our model definitions and eventually fine-tuning needs. And we definitely can't forget about ExecuTorch. You heard about it right before this. You heard about it plenty yesterday from Martin as well. But we're leveraging ExecuTorch for any of our edge case needs. Edge device, not niche. And this kind of ties into our next one, minimal code. The idea of Torchchat is that we want it to just be a pipeline. We just want to connect these libraries together and get your LLM inference pipeline working. It should be as thin as possible. It should be as easy to read as possible. And like I half jokingly say this, but if we're doing Torchchat well, we're going to work ourselves out of a job because it gets thin enough that you don't need the reference implementation. Once we get ET and PyTorch and AO all wired up properly, and it's just intuitive to do it, you don't need to look at Torchchat. You just hop to the libraries you need, and you're good. Last one before I pass it over to Jesse is interoperability. We have a bunch of models that we natively support. We have a bunch of features associated with LLM inference, as well as a bunch of platforms that we already talked about on the slide previously. And whenever we introduce any new models, any new features, or any new platforms, we're going to make sure, or at least try to the best of our ability, to make sure that it works with everything else in this, I guess, matrix tensor setup of those three combinations. And with that, I'm actually going to hand it back over to Jesse to give us some more details on this.
Cool, awesome, thanks, Jack. So like Jack said, we wanted to target a pretty broad audience. And we're offering 4 different execution modes based on your particular use cases and needs and devices that you have. The first one is eager. It's pure Python. Really easy to use. It's like 5, 6 commands from cloning the repo to get everything running to actually interacting with a particular model. You get really good support for both Linux and Mac. The second one is Torch compile. This is all about speed. Things get pre-compiled, and so we're able to run inference really, really fast. We have really good support within Linux today, where you can get both CPU and CUDA support. And then on Mac, you can get CPU support. Because for today, you can only get the CPU support on Torch compile for Mac, things are actually a little bit faster on Eager. I love that the Torch compile team is working on making this a possibility for Metal. So in the short future, you'll be able to use Torch compile with really good performance on Mac using MPS. The third one is for people who want to have a Python-less environment. This is pure C++. Everything is compiled. The binary for running it is C++. The model is C++. And so for folks who want to compile everything and port it over to a particular solution or device, this is the way to go. For folks who want to run on the edge, and there were folks here just a moment ago that were talking about ExecuTorch. ExecuTorch is the way to do that. It's great for mobile devices, IoT, robots, etc. There is a ton of support there for multiple different backends and chips. You'll get not just the CPUs, but also the NPUs as well. And so anytime you're thinking about, hey, I want to run a LLM on edge where processing is like constrained or memory is constrained, this is the execution mode to use. Model support. We wanted to make it really easy, so we integrated with Hugging Face. You can use many of the models that are already there. The code is very readable in Python, and limited changes are required to support a new model as long as Torchchat already supports that particular architecture. For example, when we supported or added support for 3.1, it was less than 50 lines of code, which is pretty cool. Today, you can get support for all the Llama models, Mistral, Stories, and like any day now, we'll have support landed for our first multimodal model, which is Lava. So anybody who's worked with LLMs knows they're really big. I mean, they're not called large for a reason. The thing that everybody thinks about as soon as they start working with LLMs is like, how do I make this smaller? And how do I make this more performant? And so we provided a couple quantization schemes and a number of data types so that you can balance the trade-offs between size and performance with correctness. And speaking of that, there's a evaluation harness so that after export and after quantization, you can review the perplexity numbers and check to make sure that you're getting the correctness that you want. We provide export tools both for AOTI and for ExecuTorch. So you can take a model, convert it into the format that you need, and then just run it. As you're running inference, you'll get performance metrics, as well as memory metrics if you're running in CUDA. CLIs, so everything is accessible via the CLI. There's a rich help. So you can always run -- help, and you can figure out kind of what's available and how to use it. You'll get that all for the utilities, model management, export, evaluation, as well as being able to interact with these models straight from the command line, no matter what execution mode you're using. We wanted to make it really easy for you to integrate Torchchat with other projects. There are thousands of projects on GitHub today that leverage the OpenAI spec. And so because of that, you can just clone one of these repos and change the URL from OpenAI or whatever that's connecting to your local API, Torchchat API. And it should just work. We also provide a web interface for people who want to interact with models in the browser. There's sample apps, both for iOS and Android. So you can spin these up pretty fast, build them, and deploy a model right then and there, and run through it. The way these sample apps are designed is that you can take the code from there and put it into your own project, so you can do LLM inference in your own solution or your own app. Performance is really important for us, and it's something that we're going to continue to drive towards. For example, since we launched in July, we've been able to improve the performance for AOTI on Linux by 4x. And now we're getting north of 140 tokens per second on an A100 at int4 for Llama 3.18b, which is pretty cool. For full precision, we're north of 80 tokens per second. For reference, like as we think about performance, the average person can read about 5 words a second. Now, there's not a one-to-one match between tokens and words. It's generally between 1.2 and 2, depending on the architecture. But let's just say 8 tokens per second. As long as we're north of 8 tokens per second, people are not waiting for the output. That said, it's not just reading, right? If you're doing agents, if you're doing RAGs, if you're doing multi, if you're doing all of these other things, it's really important for us to continue to increase the performance. And so that's something that we will continue to do. Same is true for Mac. Since we've launched, we've been able to improve the performance from like 30 to 40%. And now we're getting north of 30 tokens per second on an M3 Max at M4. Demo time. Everybody likes demos, so I'm going to do one here. And so this is running Torchchat in Linux on an A100. And the first command I'm going to run is this generate command. This is just pure eager. I've run a couple commands to download a model and set up the repo. But you can see the output here is pretty good and getting reasonable speed here. So you can see 14 tokens a second. Oops, I don't know why that went back. All right, it's going to run through it again. Sorry about that. One of the things that you'll see here too is the memory output as well. So the next thing I'm going to show here is AOTI. And so with AOTI, like I said earlier, it's all compiled. And so the first thing I'm going to do here is run the export command and create a .so file in the exported folder. So to load this model up, do export, then I'll run using pure C++. At this point, this is pure C++. And you can see the output is a lot faster, hitting 70 tokens per second. The next one is that same exported file, but using Python, so not the C++ runner. And we'll get even more performance out of it. And at this point, we're getting north of 80 tokens per second. So the next thing I want to show is quantization. So we'll get reduced size as well as increased performance. So I'm going to pass in one of our default quant configs, which is going to be int4 and a group size of 256. That'll generate my so file. And so I'll do the same thing, but just target this particular so file. This is pure C++, north of 100 tokens per second. And this final one is same file, but using the Python runner instead. One thing I wanted to call out here, it still says memory usage here is north of 16 gigabytes. This is a bug, not like the actual memory that's being used is much lower. This model is 4.7 gigs versus the other one being 16. But yeah, that's something we just got to fix. The next thing I wanted to show, and if you guys were at the talk just before us, is running Llama 3.1 8B on a mobile device. Like I said earlier, you can just open these up within Torchchat, export the model using that export tool. It's very similar to the one that I did for the .so file. Put it on the device, and then just run it. And in this case, you'll see good performance, and it should end up being about 10 tokens per second. But that's, running Llama 3.1 8B on a mobile device. Jack?
So now that we've seen what we can do, let's take a look at what we have planned in the pipeline. So as part of polishing and growing Torchchat, one of the things we're actively doing is working to strengthen the integration we have with these PyTorch offerings. For example, with torchao and torchtune, we're actively collaborating with these teams to make sure that we can pull in any new features that they come out with as soon as they're able to release. It also kind of positions Torchchat in a position where we just kind of nudge them in the direction and ask them for features, and it's kind of harder for them to say no, but that's a separate thing. We're also working on improving our performance. So this is both on the CPU side via x86 and ARM. We're also looking at the accelerator side on GPUs, GPU CUDA, and Metal. Like Jesse mentioned, currently on the Metal side, we only have Eager, but we're actively working on trying to get us compile and AOTI set up on that as well. And we expect a huge boost over there. Not mentioned here is also quantization that we're actively working on improving across these platforms. One other one that I'm going to touch on is actually Edge. So we're working on actively improving the performance on Edge, as well as increasing our breadth of support for NPUs via ExecuTorch. As new models come out, especially Llama models, we're planning to actively support those as soon as they come out, as quickly as can. And we're looking into adding diffusion models in the future as well. Moving on to the last two, these are the ones that are actually coming out the closest, and well, they're coming out in Q4, at the end of this year. First one is distributed computing. If you were at the talk yesterday by Kay, you're already familiar with this one. But currently in Torchchat, we are working on adding a distributed inference option. And currently inside of the repo, if you look under the distributed folder, you can see the existing work. And we're able to do multi-prompt, multi-GPU inference already by leveraging tensor parallelism and pipeline parallelism. The target for this one is end of November, early December for alpha. Moving on to the last one is actually something coming out of AOTI. we're working on getting a new file format out of AOTI that is more hackable. Essentially, we're going to generate a native artifact that's in C++ that'll let us go in and just change that file for whatever use case we need in our application. And we're also doing it in a way that allows you to bundle additional sources for whatever use case, for whatever application you want to serve via AOTI. Let's see, let's move on to the next one. So, we have a little bit more time, so I'm just going to leave you guys with this one. Torchchat was built for users in mind, so we'd love for you guys to hop over to the repo, give it a clone, run through the README, or if you have your own project, just grab portions of Torchchat and mix it in, try it out in your own project, let us know how it goes. And if you guys already support an OpenAI API, like Jesse mentioned, it's as simple as just switching the URL, pointing it to the Torchchat server instead of your own server. As you're doing this, if you guys run into any issues or have any ideas for how we can improve Torchchat, go over to GitHub and just spin up an issue, and we'll try to get back to you as quickly as we can. Help us build out the community over on Reddit, Local Llama, as well as Torchchat, as well as discuss.pytorch, which everyone's more familiar with. If you're interested, also just help out build out Torchchat as well. Grab some issues, let us know if you have any questions about how you can help, and we'll be glad to help you out there and review your PRs. If you're interested in publishing any tutorials and videos, tag us in it. We'll definitely help highlight those as well. And if you see any questions in any of these platforms, feel free to answer it on Reddit, GitHub, and we're definitely welcome to help. With that, here's a scannable QR code if you guys are interested in checking out the repo. It's like your normal PyTorch repo, just put a Torchchat at the end. Sweet, and we have a couple minutes for time, I think. Maybe, I think we have time. See? Oh. Yeah.
Thanks. Hi there. Great presentation. I was just wondering, are you focused on single user or looking at multi-user as well, use?
So currently the repo is mostly focused on single user, but we have some engineers on the team who are interested and are playing around with multi-user. You first? Yeah.
Hey, thanks for the great work. Any plans on Windows support?
Or?
Windows support for Torchchat. Windows.
Oh, Windows support on Torchchat. So with that one, I think it already kind of works. We haven't actively tested it, and we need to spin up some doc and README, but it might already work, I think.
Hi, yeah, thanks for the great presentation. So if you say you need some time to add new models, what do you actually need to do to add new model support, besides writing the code?
Yep. So if you're adding a new model, you only need two types of things. If you're just adding a new variant of a model architecture we already support, then it's super simple. You just edit any changes you need. Give us a params file saying oh, this is the number of heads, number of blocks, for us to actually fill in that architecture. If you're using something from, say, TorchTune, you just update a config file saying, okay, I want this encoder, and I want this particular decoder from whichever library, and we'll automatically import those for you, and then fill it in with that other param file saying number of heads, number of blocks, max sequence length you want to support. Yep, you can import your own encoder as well. Just copy and paste your bit in there, or copy and paste Torchchat to your own project, and it'll just call whatever code you put in there. Sweet. Any short question, or I think we're getting kicked out for the next person. Okay, thanks everyone.